So okay, I think the problem is solved. Please tell me. So please join. I think problem is solved now. So yes, Shubhadeep. Okay. So please join. I see only 3 people watching. Okay. 4 are there now. So can I start? Tell me. Okay. So the normal equation is I denote this by 1 and theta curl hat, which is equal to a prime a g inverse a prime y if A is not full rank matrix. Since we already know this normal equation is solvable, so this is the general solution theta curl tilde and this is equal to theta curl hat plus I minus h z curl, where h equal to a prime a g inverse a prime a, and this theta curl hat is a particular solution. Now check that this H is a idempotent matrix, that means H is square equal to H. So from the property of A inverse, this should be A prime A, then it is again H, hence H is idempotent matrix. Okay. Now A prime A H equal to A prime A, and rank of A prime A H equal to rank of A prime A and this is greater than equal to rank of H. Again, H equal to A prime A G inverse A prime A. So this implies rank of H this should be less than equal to rank of A prime. Okay, so combining these two parts, rank of H equal to rank of A prime A equal to rank of A, and we assume rank of A equal to R, so rank of H, since H is a idempotent matrix, so this is equal to trace of H and this is equal to R. Result, if SG inverse is a G inverse of A prime A, I denote this by S. So S G inverse is a G inverse of S, its transpose is also a G inverse proof. We know S is G inverse S, this is equal to S. This implies S G inverse S whole prime is prime, this equal to S prime G inverse whole prime is prime S prime. Since S is a symmetric matrix, because S is equal to A prime A, so it is obvious that S is a symmetric matrix. So S prime equal to S, hence S G inverse prime is also G inverse of S. This is result 1. Now result 2 A equal to H proof. We know SH equal to S, where H is a is G inverse S and S is A prime A. I already know this thing. Sorry, S is equal to A prime A. So from the property of G inverse, SH gives S. Okay. So therefore, S minus SH, this should be 0, null matrix. Then S minus SH if you multiply by pre-multiplication by matrix I minus H prime, then this also gives 0 because S minus H equal to 0. So I minus H, S means A prime A, then A minus AH equal to 0, A prime whole prime equal to 0. And since this is nothing but a xcal prime xcal equal to 0, so summation xi equal to 0 means all xi is 0, so this imply this should be 0, hence okay. So please tell me if you have any problem before going to the next result. Have you any problem? Please tell me, Showdeep, are you there? Okay. You can think this is a vector A minus H, same thing, same things happen for matrix also. So this should imply A minus H AH equal to 0, hence A minus H equal to A equal to AH. Okay, so mixed result, A minus S prime A prime, this is equal to A S prime G inverse A prime, and proof is A equal to AH equal to A prime A G inverse A prime A and we see that A prime A G inverse transpose is also a G inverse A prime A, so this equal to okay, this imply I denote A prime A by S this is equal to null using same procedure. S means A prime A, so therefore okay. So we need this result Next we discuss projection of on the estimation space. There is another way of looking at the blue based linear unbiased estimator of an estimable function lambda curl prime theta curl. That means lambda curl belonging to the row space of A prime. Okay. On account of estimability, there is at least one unbiased estimator estimate one unbiased estimate A curl prime y curl of lambda curl prime theta curl So this vector A curl prime y, we already see this thing A curl prime which belonging to Rn can be split into P is a matrix. Here P stands for projection matrix. And this is my claim now. We will prove it. P is a projection matrix where P equal to A S G inverse A prime. Now the property of P is symmetric. That means P prime equal to P. P prime is nothing but A is G inverse A whole prime equal to A is G inverse prime A prime, and we know already from result 2 that S G inverse is G inverse prime is another G inverse of S, hence these two things are same. So using result 2, just see the result 2, hence P is a symmetric matrix. Next property, I think result 3 na, please check. I think it is a result 3. result 3. Okay, this should be result 3. Next, P is idempotent. Can you tell me, is it result 3 na? I denote this result by result 3. Please check and tell me. Next property of matrix P is idempotent, because a P is a projection matrix, it should be a symmetric idempotent matrix. We already knew this result from our linear algebra class. Okay, so P is an idempotent matrix, that means P square should be P. Can you tell me, is it result 3 or not? If there is anybody, please tell me, am I right? Is it result 3 or result 2? Check and tell me. So P square equal to P into P, then P equal to A. Okay, thank you Shubhadeep. Only Shubhadeep responding. Another, what about the other? Oh, Sohini. Yes. Okay, Shashwati. Only 3. Okay. So G inverse A prime and using result 2, using result 3, result 3, or you can check this thing. So T square, and see that A prime A so you can the result. I recall one result for this, and that is this portion. I think S is G inverse A. This should be A. Please mention the result. Is it result 1, 2, 3? Tell me which one this. Please tell me. I think I need this result. Result H means what? H means A prime A, G inverse A prime A. Okay. Oh, Vishwanath say result 3. Okay. So this is result 3. So this is equal to A S prime A using result. No, please tell me this portion. A prime A S inverse A prime is equal to A. We need to show this thing. So please tell me which result is it? It is, I think, result 2. Result 2, because S is S is your A prime A. You know result, I think in result 2 says A equal to AH. Okay, and your H is your S, G inverse S. Okay, so then A equal to A S G inverse S. Now relate this thing, and if you take a transpose of this, then this should be S result 2 S prime this A prime. So okay, just use this result 2, we get this thing. So again it is a P. Okay, so P is a idempotent matrix. Next portion, rank of P equal to trace of P equal to trace of A is G inverse A prime. So use trace of AB equal to trace of BA. So this is equal to trace of H, and we know trace of H is equal to R. So again we see that A curl prime P, A curl prime I minus P whole prime, this equal to A prime P I minus P A curl P minus P square A curl, this is equal to 0. So A curl P and A curl I minus P are orthogonal. Now A curl prime P y curl, this is equal to A curl prime P means A is G inverse A y curl, and from normal equation we know this A y curl is nothing but A is G inverse A prime A theta curl hat, and this equal to A S prime S theta curl hat, and A curl prime A H theta curl hat. I denote S G inverse S by H, so this is a AH, and we know, I think result 2, that AH is equal to A. And this means this portion A curl prime A is nothing but a linear combination of the rows of A, and this is denoted by lambda dash, because we assume that lambda dash prime theta curl is estimable. This means lambda curl prime belonging to row space of A, so this is equal to lambda curl prime theta curl hat. since ex- expectation y curl a curl is a estimator of lambda curl prime theta curl. This means expectation a curl prime y curl equal to lambda curl prime theta curl, and this means a curl prime a lambda curl prime. Okay, just using this thing you get a curl prime equal to lambda curl prime. So from this discussion we see that a curl prime p y curl is the best linear unbiased estimator of lambda curl prime theta curl, and therefore other component a curl prime I minus p y curl is linear function belonging to is linear function belonging to the error space. Due to the orthogonality of a curl prime p and a curl prime I minus p, since a curl prime p and a curl prime I minus p are orthogonal, this means these functions, the linear functions of observations, should belonging to the error space. Therefore one means, actually I denote this, I recall this partition a curl prime p plus a curl prime I minus p. I denote this partition by 1. So from 1, this 1 shows that given an orthogonal, given an unbiased estimate of a parametric function, lambda curl prime theta curl, one can obtain unbiased estimate parametric function lambda curl prime theta curl. Okay, shows that given an unbiased estimate of a parametric function for function lambda, one can obtain unbiased estimate of parametric function. I think I should write this in that way. Okay, one can obtain the blue best linear unbiased estimate by using the matrix operator P. Okay, one shows that given an unbiased estimator of parametric function lambda curl prime theta curl, one can obtain blue by using matrix operator P. The operator P splits A curl prime y curl as A curl prime p y curl and A curl prime I minus p y curl yielding the blue A curl prime p y curl, since A curl prime I minus p y curl is a error function or belongs to error, and its expected value is 0, and provides no information on theta. So actually I start with any unbiased estimator of lambda curl prime theta curl A curl prime y curl, say, and I split this A curl into two part, that is A curl prime p, A curl prime I minus p, where p is a operator, and we see that A curl prime p y curl is a unbiased estimator of lambda curl prime y curl, and A curl prime I minus p y curl is a error function, that means it is a estimator of 0, hence it does not contain any informations about theta, therefore the information of theta only contained by these portions. So these portions gives a unbiased base linear unbiased estimator of theta. So actually, so it expected value is 0 and provide no information on theta, and simply this portion a curl prime I minus p inflates inflates the variance of a curl prime y curl. If we remove this portion a curl prime I minus p y curl, from a curl prime y curl, we get blue. So from this discussion we get a machine. This machine is called p operator. Okay, and we know the form of a p, and we start with any unbiased estimator a curl prime y curl of lambda curl prime p, and our aim is, so this is a machine first. Okay, I denote this machine by this box, and the name of this machine is p operator, and I start with any unbiased estimator of lambda curl prime y curl, lambda curl prime theta curl, and say it is a curl prime y curl, and if you put this unbiased estimator a curl prime y curl to this machine automatically break this into two parts. And after that, from this machine we get this, which is a unbiased estimator, not only unbiased estimator, minimum variance. So this gives the best linear unbiased estimator of lambda curl prime theta curl, and this residual part we thrown away. Thrown out. Okay, so this, and in the geometrical terminology, a curl prime p is the projection of the vector a curl prime on the vector space of the columns of A. We already discussed. So this is the beauty of operator. So if you use a orthogonal projection matrix or this projection matrix, then you can get a best linear unbiased estimator. So So the columns of A. So the projection vectors A curl prime on the vector space of the columns of A. So we know this thing, and this can be readily seen from P means A is G inverse A prime, and this is equal to L curl prime A curl A prime L curl prime A prime, where L curl prime equal to L curl prime A is G inverse. And the other component and the other component A curl prime I minus P is orthogonal to the columns of A as A curl prime I minus P A equal to A curl prime A minus A curl prime P A A curl prime A minus A curl prime A prime A G inverse A prime A. This is a P, and A curl prime A curl prime, and this portion I denote this portion by H, so this is AH, hence A minus A equal to AH, so this should be 0. Thus A curl prime P is the projection of A curl prime on the estimation space, and this P is called projection operator. Now you see that you have a projection operator box, P operator. Now from this you get this portion. Now if you enter this portion, because you thrown out this portion A curl prime I minus P y curl, now you start with this unbiased estimator of lambda curl prime theta curl and check that what happened. If you put this in this box, and automatically it divided into two parts. Okay, and see, P is idempotent matrix, so this portion is same as this, and you check that this part should be 0. So no part. So with us find that no part of P A curl prime P y curl is thrown out, and A curl prime P y curl comes out as it is, showing that it is blue in fact. This is not surprising, as A curl prime P is in the estimation space and so it is projection on the estimation space itself. And we knew this thing from linear algebra class. So from this discussion we see, if you have, so this is the summary of this discussion. So from this discussion we observe that if you have a unbiased estimator of lambda curl prime theta curl, I denote this by A curl prime y curl, and then you put this thing into this box P operator, and this automatically break into two part, because this portion does not contribute theta, or this portion theta does not involve these portions, so we thrown out this portion and this gives base linear unbiased estimator of theta. And we also observe that because this is a projection on the estimation space, if you put this thing again in this P operator box, we get same things A curl prime P y curl, hence this is a base linear unbiased estimator. So from these discussions, if you have a unbiased estimator, then using operator, projection operator, you can get base linear unbiased estimator. Okay, so if you have any doubt, please tell me. Please tell me if you have any doubt. Can you hear me? Please tell me if you have any doubt. সোহিনী, শুভদীপ, শাশ্বতী, স্বর্ণেন্দু, বিশ্বনাথ, tell me. So actually from this discussion we get a operator, projection operator, which helps us, okay, which helps us to find best linear unbiased estimator. Okay, this is the thing. Actually in linear algebra class we already told you the projection operators gives you the best linear unbiased estimator. This is the reason. Okay. Now the result, suppose expectation of y curl equal to a theta curl and dispersion of y curl equal to sigma square in. In is identity matrix of order n. First part is lambda curl prime theta curl is a parametric function which is estimable and this is happened if and only if lambda curl prime belonging to row space of A, that is equal to row space of A prime A. And secondly, lambda curl prime theta curl is estimable if and only if lambda curl prime equal to lambda curl prime H, where H equal to S G inverse S and S is equal to A prime A. Proof. The normal equations is A prime y curl or this imply I denote A prime A by S, so S theta curl equal minus A prime y curl. This is where S is equal to A prime A. I denote this by a prime y curl by q curl. Now theta curl hat is a general solution which is equal to s prime q curl. This is a particular solution. See, theta curl hat equal to, from normal equation, a prime a g inverse a prime y curl. A prime y curl is q curl, and a prime a g inverse. Just see, this is a particular solution. I denote this by theta curl hat, not q curl, because I denote this a prime y curl by q curl, and so this is equal to s g inverse q curl. So theta curl hat general solution of this equation is equal to s g inverse q, which is a particular solution, plus I minus h. This is the general this is the solution belonging to the error space, where z curl is a arbitrary vector again. We have seen that lambda curl prime theta curl is estimable if and only if lambda curl prime theta curl hat is unique of for any solution of normal equation, that is lambda curl prime theta curl hat. So this is equal to theta curl hat means this is g inverse q curl plus I minus h z curl, and this is equal to lambda curl prime is g inverse q curl plus lambda curl prime I minus h z curl, and equal to lambda curl prime is g inverse q curl plus lambda curl prime h z curl. And since z curl being arbitrary, and lambda curl prime theta curl hat should be unique if and only if this portion should be 0. So this means okay, So this is a proof of second part. First part you know this thing. We already proved this part. First part, okay. Please tell me, have you any doubt? Sharupo? Are you hear me? Have you any doubt? So let lambda 1 curl theta curl, lambda 2 curl theta curl, lambda k curl prime theta curl be k estimable parametric function with be k estimable parametric function with the blue is with blues actually T1 T2 Tk respectively. Then sum over Ci lambda I curl prime Ti Ci lambda I curl prime theta I is also estimable with the blue I from 1 to k Ci Ti. Lambda I curl prime theta curl is estimable for all I. This means lambda I curl prime belonging to row space of A. So linear combination of this lambda I curl prime also belonging to row space of A, because all lambda is belonging to row space of A, because lambda I prime theta curl is estimable. So this imply Ci lambda I curl prime theta curl equal to I from 1 to k Ci lambda I curl prime theta curl is also estimable. Okay. Now Ti equal to blue of lambda I curl prime theta curl imply Ti is of the form Q curl prime A Y curl. We already seen this thing in our previous class, such that Q curl satisfy this equation. I denote this by Qi curl, the form Qi curl prime A prime Y curl. So such that this portion Qi curl prime Qi curl prime satisfy this equation. One to K. Now T equal to sum over I from 1 to K Ci Ti. So this is equal to I from 1 to K Ci Ti means Qi curl prime A Y curl prime Y curl sorry so Ti is of the form Q prime A prime. This is the mistake, please rectify this thing. Qi curl prime A prime Y prime and Ci Ti means Qi prime A prime Y curl. And see that T equal to the coefficient vector of T equal to Ci Qi curl prime A prime I from 1 to K. So this is belonging to the column space of A. Sorry, this is mistake. Actually, coefficient of Ti means prime of this portion. So this should be Ci A Qi curl prime Qi curl. So this is belonging to the column space of A. Okay. So therefore T is the best linear unbiased estimator of Ci lambda I curl prime theta curl if expectation of T is equal to and qi a prime a, this portion is a lambda I. See that lambda I curl prime theta curl, so which is a linear combination of lambda 1 prime theta curl, lambda 2 prime theta curl, lambda k prime theta curl. So hence T, which is a linear combination of TIs, is the blue of sum over Ci lambda I curl prime theta curl. So please tell me if you have any doubt. So please tell me, have you any doubt? Can I rub this portion? সোহিনী রুচিরা শাশ্বতী স্বরূপ বিশ্বনাথ স্বর্ণেন্দু, please tell me, can I rub this portion? Are you there? Have you any problem? Please tell me. No problem. If you tell me repeat this prop, I have no problem. I can do this thing. Okay. So next thing is variance, covariance of blues. So let lambda curl prime theta curl and mu curl prime theta curl be two estimable parametric function we know that lambda curl prime theta curl hat and mu curl prime theta curl hat are the blues of lambda curl prime theta curl and mu curl prime theta curl respectively. This is from Gauss-Markov theorem. We know that we actually the problem is to find variance of lambda curl prime theta curl hat and covariance of lambda curl prime theta curl hat mu curl prime theta curl hat. Case 1, That is full rank model. And in that case, first we consider the normal equation, and in that case A transpose A invertible, so this is equal to this, and the blue is lambda curl prime theta curl is lambda curl prime theta curl hat, which is equal to this, and the variance of okay, just applying this result, variance of or dispersion of this is nothing but A dispersion of y curl A prime. I use this thing here. Okay, so this is equal to lambda curl prime A prime A inverse lambda curl sigma square. Similarly, covariance of lambda curl prime theta curl hat mu curl prime theta curl hat, this is equal to sigma square lambda curl prime A prime A G A prime A inverse lambda curl mu curl, sorry. Check this thing. So now case 2, A prime A is not a full rank model, not a full rank, and a solution of the normal equation this is the normal equation is given by theta curl prime theta curl hat A prime A G inverse A y curl. The blue of, I denote this by matrix S by C, because we already defined matrix S, which is A prime A. So C is a G inverse of A prime A. The blue of lambda curl prime theta curl is equal to lambda curl prime theta curl hat is equal to lambda curl prime theta curl hat is CAY curl. Okay. Now variance of lambda curl prime theta curl hat is equal to variance of lambda curl prime CAY curl, which is equal to sigma square lambda curl prime CA, actually CA transpose, I think it is a transpose. Okay, please rectify this thing. So sigma square sigma square so sigma square lambda curl prime CA A prime A C prime lambda curl, this is equal to sigma square lambda curl prime C is C prime, which I already defined S is A prime A. So this is the variance of lambda curl prime theta curl hat. Now as lambda curl prime theta curl is estimable, then lambda curl equal to A prime A Q curl. So this is equal to S Q curl for some Q curl. So variance of lambda curl prime theta curl hat, this is equal to sigma square lambda curl prime CS C prime SQ curl and see that S G inverse S S, so this is equal to lambda curl prime C S Q curl. And this is equal to lambda curl prime C and SQ curl is lambda curl. Okay. Similarly, we can prove that covariance lambda curl prime theta curl hat mu curl prime theta curl hat, this is equal to mu curl prime C lambda curl sigma square equal to lambda curl prime C mu curl sigma square. So please check it. This is your homework. Okay. So now this is the last result for today class. In my next class we will discuss canonical form of the linear models, estimation under correlation model, and estimation where parameters obey some linear restrictions. Okay. And if time is permit, we will discuss sum of square due to linear functions. So this is the last remark for today class. In full rank case, theta curl hat equal to is inverse A prime y curl. So expectation theta curl hat, this is equal to is inverse A prime A theta curl is equal to theta curl, because S is A prime A equal to S. So in that case theta curl hat is an unbiased estimator of theta, and dispersion of theta curl hat is equal to sigma square S G inverse S inverse. Check it. Therefore, variance of lambda curl prime theta curl hat is sigma square lambda curl prime S inverse C S inverse lambda curl. So which is same thing for when the rank is not full. Okay, just replace C means G inverse of S, just replace G inverse by inverse because it is a full rank model. And but therefore you can say that, but if rank of A prime A less than P, that is non full rank model, theta curl hat equal to C A prime y curl, where I already mentioned this thing, C is a G inverse of S, then expectation theta curl hat is C A prime A theta curl, but this thing is not I identity matrix, and it is I only when this is a full rank matrix. That means C is a inverse of S. So this is not equal to theta curl. always. So dispersion of theta curl hat is meaningless for the case of non-full rank model. So dispersion of theta curl hat only meaningful when it is a full rank model, otherwise it is meaningless. And we also observe that for non-full rank model, theta curl hat is not a unbiased estimator of theta curl. So please tell me if you have any doubt. I want to end the stream. I give you 5 minutes. Please tell me. Thank you. So please tell me, have you any query? Sohini, Shashwati, Ruchira, Swarupo, Vishwanath, Swarnendu, please tell me, have you any doubt? Shubhadeep, please tell me, have you any doubt? I want to end the stream now. So from this remark we observe that theta curl hat is unbiased estimator only when it is a full rank model, otherwise it is not an unbiased estimator, and hence for non-full rank model dispersion of theta curl hat is meaningless, and it is meaningful only when it is a full rank model. Okay, so next day we will discuss canonical form of the linear model, then estimation under correlation model, estimation where parameters obey some linear restrictions, and if time is permanent then we will discuss sum of square due to linear functions. Hopefully this is the last class for linear model. Next is the last class for the linear model. So please, thank you, please stay with us. We will meet again on Thursday at 10 a.m. Till then, bye. Okay.